trial and error is one of the most important aspects of problem solving. It's one that you often don't see when you see a problem solved presented in a textbook or class or a research paper. The tendency is almost always to only present the correct solution, the one that worked, and you don't see the outtakes, which is a shame, actually, because that's often the most informative part. We don't often show how embarrassing these stupid first attempts at solving a problem. But it is extremely important. And you need to have the freedom to try things that are potentially stupid. Well, because A, they might actually work, but B, because the way in which they fail is often very instructive. It gives you clues to figure out what the solution should be. I think the physicist Niels Bohr once said that an expert is someone who has made all the mistakes that can be made in a very narrow field. That the only reason why experts seem so competent is because they've already screwed up in every conceivable way, that they know how to not do that in the future. I must confess that my first 1 or 2 years in graduate school were not super productive. I did some math, and I took some classes, but I did spend too much time doing computer games and discovering the World Wide Web, which was very recent at that time. So about halfway through graduate school, there was this rather intimidating exam, which we called the general exam, or the generals. It's a 2 or 3 hour oral exam where you pick 3 topics in mathematics, and 3 faculty in the department, they quiz you about these topics, and if you get the questions right, they ask you even harder questions. If you get them wrong, they ask you easier questions. Most of the other students in my class, they spent months and months practicing this. They quizzed each other. They had these mock general exams. I basically studied a little bit, maybe for a few weeks, but I'd figured I would wing it. I did not do very well. My knowledge was very superficial. Whenever there was a follow-up question, I could not provide a good answer. And the questions became easier and easier, and I could barely solve most of them. The only reason I even passed the exam was because the one topic which I thought was the most challenging for me was the only one I actually tried to study for. And that one I actually managed to answer enough correct questions that I could pass. But my graduate advisor afterwards took me aside and said he was quite disappointed in a very gentle and encouraging way, and that I really should try to do better. I was used to doing well in mathematics without working super hard. And so it was a shock to me to realize that that mode of thinking had limits, that you had to think more systematically, you had to actually plan your study, you have to actually learn from your mistakes. And so, yeah, those were important life skills to learn. One famous example of an experiment that failed and led to an interesting discovery was the story of the Greek philosopher Eratosthenes. So many, many years ago, he lived in a city in Egypt called Alexandria. And he read that there was another city, another town called Syene, which had a well in it. And this well had the funny property that on one day of the year, the summer solstice, if you looked at high noon into this well, the sun was directly overhead, and you could see the sun reflected in the water deep below. Eratosthenes was intrigued by this story, and so he decided to wait until the summer solstice in his own town of Alexandria and go to his own local well. And he found that at noon that the sun did not shine straight down. It was at an angle. So his experiment failed. And for most people, they would just say, okay, this was, I guess the modern term was fake news, okay, that this story just wasn't true. But what Eratosthenes realized is that because the experiment failed in his city, but didn't fail in this other city, that the Earth must be curved. And furthermore, he realized that, in fact, he could now use this failure to measure the size of the Earth. And in fact, he was the very first person to actually get a pretty good measurement, I think within 10% accuracy. And all he did was he measured the angle that the sun made at Alexandria. He knew the distance between Alexandria and Syene. It was a couple hundred miles. And the mathematics of the time was fairly primitive, but still good enough to get a pretty good measurement. So sometimes a failure can be extremely productive. This happens all throughout science. I think penicillin was discovered by accident, that someone left a jar of bacteria called moldy or something. The great thing about mathematics is that failure is cheap. In a practical discipline, if you fail at, say, building a bridge, you may cost lives or lots and lots of money. But if you try and solve a problem, like you solve for x and you don't get the right value of x, it's okay. You just go and fix your problem. You try again. There was a famous mathematician, Vladimir Arnold, that said that mathematics is the part of science where experiments are cheap. You can try almost anything. You just need a blackboard and a bit of time. And just getting into a mindset where the goal is not necessarily to solve the problem quickly or efficiently, but to enjoy yourself and to draw lessons from it. If you start doing that in your life, I think maybe it will just naturally become just part of your way of thinking. It's just another way of going through life. Sometimes a failure can be extremely insightful and productive. It can be a sign that there's something more going on than you expected, something unexpected. Isaac Asimov once said that the most exciting sentence that a scientist says is not eureka, but that's funny. Okay, there's something unexpected, something that didn't go as planned. That's not a failure. It's often a clue that there's something new and exciting is going on. People often think that the way math or science works is that people work very hard on a problem and there's no progress for a long time. And suddenly there's a eureka moment. Some lightning bolt hits you and suddenly everything gets illuminated and you find the right way forward. That's not quite how it works in my experience. You do work for a long time on a problem, and it's frustrating because you're not making visible progress, but you're making a lot of progress underneath the surface. You are working out what doesn't work. You are finding partial solutions. You're realizing connections with other topics, and you're just setting the stage for putting the problem in exactly the right perspective. It often is a very small thing. It's a very last puzzle piece to put into place, and suddenly everything makes sense. It's rarely a big lightning bolt of clarity. It's just it's more like a realization that you are almost there already. That a lot of the insights, partial progress that you had, actually it just takes one last ingredient to make it work. When you fail at a task, maybe the most natural thing psychologically is just, okay, that sucked. I don't want to do this. Maybe you blame yourself. When failure occurs, it's very natural to try to find the person to blame. But mathematical problems are not like that. Often what you need to do is just not so much to assign blame, but to figure out what was the specific aspect that was blocking this approach from working. You have to look at the precise point of failure, and it will often tell you a clue as to what the working solution should look like. It's actually not the solution to specific problems that is so important for us, but more the process and what we learn from the journey in asking these questions. So what are the takeaways? Firstly, don't be afraid to fail. Try to avoid blaming a failure on yourself or others. Remember that failure is often what provides us the clues to a correct answer. Figure out what doesn't work and why. Persistence is key. Stay patient. It's all part of the process.